Hello students, welcome back. Today we'll be working on our next section, which is exponential functions. So y equals e to the x, and doing the derivative for y equals e to the x. So we're going to look at doing a little translating just to make sure that you are aware of the translation back and forth, and a little bit of solving equations as well. So in that first example where you are writing the exponential as a logarithm, I just want to remind you that we would write the exponent -2, and that equals the log with a base of e, which we write as ln, of 0.1353. So 0.1353. So that's just making the translation to a logarithm. Likewise, if you have a logarithm and you want to change it to an exponential, ln has a base of e, then the logarithms equal exponents, so the -0.6931, and I don't have all of it, so we'd have to know exactly what that is, equals, and then the 0.5. And of course, you would need a calculator to get that exact value. To solve an exponential equation, I want you to remember that if you do not have a logarithm, you can simply put the exponent, which in this case is a logarithm. So the exponent equals, and then log base e, here's your base. So since I've got log base e, I can just put ln, and then of the argument 4. And then you look to see what you have. Since you have logs on each side, you can cancel those and solve that x would equal 4. So there's a solution to that exponential equation. If you have a logarithmic equation, remember that your base is e, your exponent, logs equal exponents, so e to the 10th would equal the argument x squared. Now, I do this one because I want you to know you square root each side. And so when we square root on e to the 10th, then you get x equals, so when you square root, you get two answers, so plus or minus. And remember that exponents, this is to the 10th power, and the square root is a 1/2 power. And so the exponents would multiply, and you would get e to the 5th power. So in other words, it just divides by 2 when you do the square root. The exponent divides by 2. So plus or minus e to the 5th. All right, then we'll take a look at the graph of y equals e to the x. So I've gone ahead and gotten that on Desmos. This is a picture of y equals e to the x. Notice that it is a continuous graph. It's increasing. It's concave up. It does have an inverse. It's 1 to 1. The domain is -infinity to infinity. The range, however, has a horizontal asymptote of 0, so begins at 0 and goes to infinity. So those are some things we'll fill in, along with a little bit of the table. And this is just to get you more aware of the graph. So let me get my pen back the way I like it here. So for e to the -2 power, I'll just go ahead and give you these decimals. You can look them up on Desmos. So remember, maybe the biggest thing that you might want to remember is that that is 1 over e squared. That's what that means. E to the negative 1, 1 over e. So notice that these y values are never going to get into the negatives. E to the 0 is 1. E to the first is just e, and so 2.718, and it goes on. And then e to the second, and when we talk about exponential growth, you can really see it with a base of e. It grows very, very quickly. And then as we're looking at the graph, again, the domain is negative infinity to infinity. The range is from 0, not including the 0, to infinity because it has that horizontal asymptote. It was a continuous function, so continuous, increasing, and 1-to-1. So this is just a little bit about the function y equals e to the x. It is concave up. And then some exponent rules. We did these with when we were looking at logarithms. I want to emphasize them one more time. If you're multiplying, then the bases, when they're the same, the exponents will add. So keep the base, add the exponents. When you're dividing, keep the base, subtract the exponents. And then just something to notice about the graph, as x is going to negative infinity. So if we look at the graph again, negative infinity is over here. The y value is going to 0. As x is going to positive infinity, this graph is just climbing higher and higher. So it's going to infinity. So this one would be 0, and this is going to be positive infinity. So that's just a little bit about e, but we're going to do the derivative. I think you're going to like this derivative because e to the x, its derivative is itself. And so the derivative of e to the x is e to the x. Of course, most of the time, your exponent is going to be something other than just an x. So there's a bit of a chain rule. It will be e, and you'll keep your exponent, and then you'll have to multiply by the derivative of the exponent. So we'll take a look at our examples of finding the derivative. So your first one is y equals e, and then your exponent is negative 2x plus x squared. So y prime would equal e, and you keep your exponent, so e to the negative 2x plus x to the second, and then you'll have to multiply by the derivative of that exponent. So that'd be negative 2 plus 2x. And oftentimes the e is written second. I don't know that that's really all that important, but just it maybe would look a little different to you. So putting the negative 2 plus 2x in the front, and then e with its power in the back of that factor. All right, your second one, a little more complicated. Remember that it involves a logarithm. So whenever we can rewrite with a logarithm, we should, possibly do that. And so you could do a rewrite in a couple of ways. But since we've got a logarithm, I'm going to do it like this. It's a division, so I can do the log of the numerator, e to the x plus e to the negative x. And then division becomes subtraction, minus the log of 2. Now, when I do the derivative of this, so y prime, it's a logarithm, so I have to do 1 over my argument. So 1 over e to the x plus e to the negative x, but I then have to multiply that by the derivative of that argument. So the derivative of e to the x is itself e to the x. And the derivative of e to the negative x is itself. So I could say plus e to the negative x, but then I have to multiply by the derivative of the negative x, which is negative 1. So I think I'm just going to erase the plus sign and put subtraction. So minus e to the negative x. And then something to notice here, this log of 2, that is a constant, and the derivative of a constant is 0. So we'll simplify this by rewriting it as one fraction, e to the x minus e to the negative x, and then your denominator, e to the x plus e to the negative x. Now this is tempting to cancel these e to the x's. You cannot, they're connected. However, often we do have some simplifying. So we're going to factor out, we have e in common, and your lower exponent would be the negative 1. So I'm going to factor out e to the negative x. And then remember that factoring is like dividing. So just a little extra work here off to the side. If I would take e to the x and divide it by e to the negative x, that's what factoring is, then I would get e to the x minus negative x. And that becomes e to the 2x power. That is a calculation that's going to happen quite a bit. So this becomes e to the 2x. So again, factoring out e to the negative x from these two terms, I get e to the 2x minus, and then e to the negative x factored out of itself leaves me with a 1. And then my denominator, I have a very similar situation. I'll factor out e to the negative x. And so for this term, that will leave me with e to the 2x, much as I had here, plus, and then e to the negative x. When I factor out itself, I get a plus 1. And so I would be able to cancel these because they're not connected with plus signs. So my final answer would be this fraction of y prime equaling e to the 2x minus 1 over e to the 2x plus 1. A very common scenario when working with e. So make sure you look back at that as you need it. And then for this lesson, we're going to go ahead and look at a couple of what I guess I would say are applications. One is finding the equation of the tangent line. So when you're finding the equation of the tangent line, that needs to signal you that you need to do the derivative so that you can find the slope to begin with. So if we start off with your derivative, y prime would equal, we keep e and its exponent, and then we multiply by the derivative of the exponent. So your slope formula is negative 2e to the negative 2x. So then we have at x equals 0. So at, let me erase that. I wanted that to be in a different color. So at x equals 0, your slope would equal negative 2e to the negative 2 times 0 power. So that would be negative 2 times e to the 0. E to the 0 is 1. And so negative 2 times 1 will give me negative 2. So my slope is negative 2. Now, I need to find the equation of the tangent line. So this is not finished. The next thing that I'll need to do is I need the y value. So again, at x equals 0, I have y equals e to the negative 2 times 0 so that I can find my y value. So that would be e to the 0 power. And so my y is a 1. And so I have my ordered pair of 0, 1. And then finally, I can find my equation. Now, your tangent line is y equals mx plus b. This point right here actually is the y-intercept, but just in case you need a refresher, if that is not the y-intercept, you would plug in, of course, 1 for the y equals, and then your slope, negative 2, and your x, which is a 0, and then plus b. And so negative 2 times 0 is 0, so your b is 1, and your equation y equals negative 2x plus 1. That would be the equation of the tangent line to the graph of y equals e to the negative 2x when x is a 0. And just to take a look at that on Desmos, so y equals e to the negative 2x, there's your graph. And then we got y equals negative 2x plus 1 as our tangent line. So at 0, 1, this is the one point that those two graphs have in common, is 0, 1. That's what makes it a tangent line. Its slope is negative 2, and you were able to find that with just that one point. So it's just been a while since we've talked about that. And then finally, the last example is just doing some implicit differentiation. And so we've got this expression, e to the xy, that we're going to have to deal with in this equation. So we'll do the derivative with respect to x of this equation. So e to the xy plus x squared minus y squared equals 10. We're going to do the derivative with respect to x of each term. So I think I'm actually going to show that to you, the derivative with respect to x of e to the xy. And then the derivative with respect to x of x squared minus the derivative with respect to x of y squared equals, and then the derivative with respect to x of 10. So the first derivative that we have to do involves a product. So as we are doing the derivative of this exponent, we'll need to remember that we have a product rule. So the derivative of e to the xy is itself e to the xy times, and then a product rule. So it's first times the derivative of the y. Well, that would be 1 and then dy dx because it's a y. So there's first derivative second plus second times the derivative of the first, which would be a 1 because that's an x. So there's the e to the xy completed. Plus, and then the derivative of x squared would be 2x. We have minus the derivative of y squared, 2y, but it's a y, so dy dx, equaling, and then this is 0. So depending on what you have to do, you will possibly need to get the dy dx by itself, and that's what we need to have happen here. So there's no really good way to do this other than to remove the parentheses by the distributive property. So I'll have e to the xy times x times dy dx plus, and then e to the xy times y. And that removes the parentheses, plus 2x and minus 2y dy dx equals 0. Then I want to get the terms that have the dy dx on one side and everything else to the other. So I want to keep on this side the e to the xy times x times dy dx. I want to keep it over here along with the minus 2y dy dx. I want to keep it. And then I want to move to the other side, this term. So subtracting it over, negative e to the xy times y. And I want to subtract over the 2x, so minus 2x. So on this side, I can factor out. I'm going to do that in a different color so you can see it a little bit better. I'm going to factor out the dy dx. And that will leave me with e to the xy times x. I might put that x in the front. And then minus 2y. And then on the other side, I might put the y in front. So negative y e to the xy minus 2x. And then the very last step is I want to get this dy dx by itself, so I'll need to divide by this parentheses. So my final answer, dy dx, will equal, in the numerator, I'll have this part of the equation, so negative y e to the xy minus 2x. And then in the denominator, I'll have the parentheses of x e to the xy minus 2y. So you'll need to be sure that you write very neatly and keep track of where your dy dx terms are as you do this. Of course, if you had to do anything with that, you would need an ordered pair because you need to sub into both x and y. So you're doing derivatives today with e to the x power. Remember, it is itself. And then if the x is some kind of function of x, you have to do the derivative of that and multiply it. All right, so good luck with your homework, and let me know if you have any questions.